All right, so I think this is recording. Let's take a look. This problem is similar to the problems 1 and 2. They're giving us the graph of an exponential function, and they're asking us to come up with the equation. And in the previous ones, there has only been one transformation each time. So let's take a look and see what we have here. My exponential functions have the form that y is equal to b to the x power. And I know that if it's increasing as you move to the right, that b is greater than 1, and I know that if it's decreasing as you move to the right, that b is less than 1. So right away, with this going down as I move to the right, I'm expecting for my answer here to be a proper fraction, to be a fraction, a number that's less than 1. All right, so what else can I determine from this graph? Well, this is different than problems 1 and 2. This graph has a different horizontal asymptote. The basic exponential function has a horizontal asymptote that's the x-axis. But it looks like here the horizontal asymptote is the line y equals 1. The basic graph has been lifted up 1 unit. So out here, this is the y value, and if you add or subtract to the y value, that's going to change the graph vertically. So I'm suspecting that that this is the form of my answer. Now, I want to try and figure out if there's any kind of shift to the left or to the right, and then also what I really need to determine is this base that's less than 1, what its value is. Now, normally the exponential function goes through the point 0, 1. Now, when this graph is lifted up 1 unit, look, it looks like 2, 0. So it looks like there was no shift of this graph to the left or to the right. So, shifts to the left and to the right affect the x-coordinate, and it's kind of bizarre in its behavior. So I think that we have some b to the x plus 1 where b is less than 1. Well, let's look now and see if we can find another point that this graph appears to be passing through. It appears to be passing through this point, which is negative 1 comma 4. So on the left hand side of this equation, when y is 4, we know that x is negative 1. Let's see if we can solve this equation for b. Let's get b by itself by subtracting 1 from both sides of the equation. And a negative exponent will never make your answer negative, but it does change the location of the base within a fraction. So if I'm trying to solve for b here, this 3 over 1, I'm going to leave it like it is, but I'm going to write this b with a positive 1 exponent by moving that b down to the denominator and changing the sign on the exponent. Okay, so now I have a proportion. Well, one property of proportion is that if you take the reciprocal of the left-hand side, you have to take the reciprocal of the right-hand side. If I flip the left-hand side, that's what it means by taking the reciprocal. And then if I flip this, take the reciprocal of the right-hand side, and b to the 1 is implied, so I'm just going to write b. Hey, I've got my value of b, and if b is 1/3, agrees with my thought that since this was a decreasing function, that base was going to be a number that's less than 1. So here was the form of my answer, but now I know that this b is 1/3, and that's being raised to the x power, and this whole graph is being lifted up 1 unit. So there's the equation for this graph, and I hope it helps. Talk to you later.